Here we are going to discuss a question from the chapter Mathematical Induction. Here question is, prove by the principle of mathematical induction for all n belonging to the set of natural number n, capital N. Okay. Here given statement is 10 to the power 2n minus 1 plus 1 is divisible by 11. Okay. So here we will be using principle of mathematical induction. So this statement is given here, mathematical statement, and mathematical statement is denoted by Pn. So let us see the solution. Here given mathematical statement Pn is 10 to the power 2n minus 1 plus 1 is divisible by 11. Okay, let us call it relation number 1. This is the given statement. And as we know, while we are using principle of mathematical induction, the first step you have to show that this statement is true for n is equal to 1. Means we first of all we show that P1 is true, putting n is equal to 1, P1 is true, first step. Second step, we assume that PR is true, means we put n is equal to R here and we assume that this statement is true. And third and last step, we put n is equal to R plus 1 and we here show that PR plus 1 is true. So first step to show that P1 is true. First of all, as a first step, we have to show that P1 is true. And how we will get P1? By putting n is equal to 1 here. So therefore, putting n is equal to 1 in relation number 1. So we will be getting here P1 by putting n is equal to 1. So here this is 10 to the power 2 into 1 minus 1 plus 1 is divisible by 11. Okay. And you see here 10 to the power 2 into 1 minus 1 and plus 1 is equal to how much? This is 10 plus 1. 2 into 1 is 2 minus 1 is 1. 10 to the power 1 is 10. So this is equal to 11. This is 11 into 1. 11 is a factor here. 11 into some natural number. So therefore this is divisible by 11. It means that is P1 is true. Second step, we assume that PR is true. So assuming PR is true. How will get PR? Putting n is equal to R here. N is equal to R. So putting n is equal to R in relation number 1. So we'll get here PR will be in relation number 1, you see here 10 to the power 2R minus 1 plus 1 is divisible by 11. Let us call it relation number 2. And third and last step, here we have to show that P R plus 1 is true. We have to show it. So for this, we are putting n is equal to R plus 1 in relation number 1. So we will get P R plus 1 here. So therefore, putting n is equal to R plus 1 in relation number 1. So we will get here PR plus 1 is 10 to the power 2 into r plus 1 and minus 1 plus 1 is divisible by 11. We have to show it. This is divisible by 11. So we will simplify, we will expand it, and we will use here relation number 2. And with the help of this relation number 2, here we will try to show that 11 is a factor here. So it will be divisible by 11. So here, therefore, 10 to the power 2 into r plus 1 minus 1 plus 1, this can be written as 10 to the power 2r plus 2 minus 1 plus 1. So this is equal to 10 to the power 2r plus 1 plus this one here. Okay? But we have to try to convert this expression in this form, 2r minus 1 format. So this can be written as, this is 10 to the power 2r minus 1 plus 1 is here. It should remain here plus 1. So let us write here plus 2, means 10 is square, and then plus 1. So this is 10 is square is 100 into 10 to the power 2r minus 1 plus 1. And this can be written as 100 into 10 to the power 2r minus 1, and this plus 1 can be written as plus 100 minus 99. So what is the benefit of writing in this form? So that we could take here 100 common. So this is 100 into 10 to the power 2r minus 1 plus 1. 100 is common, and minus 99. Okay? So you see here relation number 2. Here we have already assumed that this is divisible by 11. Means 11 is a factor here. Correct? So we can write this is equal to 11 times of some constant k, because 11 is a factor here. So by using this concept, we can write this is equal to 100 into 11k, and this 99 is minus 11 into 9. We are writing it by relation number 2. We are using this property by this value by relation number 2, because this is divisible by 11. So 11 is a factor here. So 11 into some constant or some natural number or some positive integer. Okay. So we are writing in this form, and this is equal to, here 11 will be common in these two terms. So 11 into, this is 100k minus 9. Correct? So here 11 is a factor. So this is divisible by 11, which is divisible by 11. Means this expression is divisible by 11. It means PR plus 1 is true. Therefore, PR plus 1 is true. So this is the third and last step. At the last, we will write one line statement here. Therefore, by the principle of mathematical induction, Pn is true for all n. So true for all n. So we are proving the question here. We are getting the result. Correct? So these are very important steps to follow in principle of mathematical induction. First step, we show that P1 is true. Second step, we assume that PR is true. And third step, you show that PR plus 1 is true. Then by the principle of mathematical induction, this given statement is true for all n proved. Okay, thank you very much for watching this video, and we will see some more questions in other videos too. Thank you very much.